we're going to start our unit on volume, and you're going to have 5 different lessons on volume, and we're going to start with volume of prisms and then move on to volume of cylinders. And you're going to see that finding the volume of prisms and cylinders is very similar. Okay? So to start, let's see if you remember the names for these two figures, because these are the two figures that we're going to find the volume of in this lesson. Okay? So pause the video right now and try to remember what these two solids, geometric solids, are. Okay, well hopefully you figured out that this one was the rectangular prism, because its base, if you look here, its base is a rectangle. Here's its base right here. Okay, and that forms a rectangle. This figure is a triangular prism because its base, as you can see, is a triangle. And these are the two types of figures that we're going to find the volume of today. These are prisms because they have two parallel bases. Okay, so you can see the base right here, but it also has a top base. Okay, and they are parallel to each other. And the same thing here with our rectangular prism. We've got a base here and a base here, and they're going to be parallel to each other. So if you were camping, okay, in a tent, and you looked directly above this tent, what geometric figure would you see? So if you're staring from above it, what would it look like? Well, it would look like a rectangle. Okay. Now you can't see that rectangle, but it is in there. If I wanted to draw it, okay, it would look like this. That line's supposed to be straight. Okay, so there would be like the floor that you would be sleeping on. Okay. And what formula would you use to find the area of this rectangle? Well, you would use area equals length times width. Or you could use base times height. It doesn't matter, it's the same thing. Okay. So what exactly is volume? Volume is the amount of space a figure occupies. Okay, and we're talking about three-dimensional figures here. And sometimes you'll hear me call it geometric solids. What we're trying to find out is the amount of space that takes up. It's three-dimensional. Okay? So if we're trying to find the volume of a rectangular prism, what we're going to do is we're going to use this formula right here. This formula right here, volume equals base times height, is the generic formula that we're going to use for every single volume formula that we use. Every single figure that we find the volume for, we're going to start with this formula right here. What we're going to do then is we're going to take this B, this capital B, which stands for area of the base, and we're going to make it more specific to the figure, to the geometric solid that we're trying to find the volume of. So we'll start with this formula, and then we're going to rewrite it and change that capital B depending on what the shape of our base is. And for a rectangular prism, you can see it's right here, length times width. Okay? So you're going to be writing this formula first, then you're going to be writing the more specific formula for it. And if you take a look, all volume is, if we scroll down here, we're finding the area of the base. Okay? Once we find the area of the base, which you can see in this figure right here, we multiply it by the height, meaning we have one layer right here on the base. The height tells us how many layers there are of that base. So in this figure right here, if this is your area, which is 6 by 6, that area is 36 cubic inches. But we are going to have 2 layers of it. So if we take 2 times 36, our volume is going to end up being 72 cubic centimeters. Okay, so really what we're doing is we're finding one layer, which is the base. And then we're going to multiply it by the height, because the height tells us how many layers of this one base there is. Okay, let's look at an example here. Okay, find the volume of the rectangular prism. Well, here's our rectangular prism. Okay, here's our base. Now sometimes it helps if you color in the base. That's what I usually do. I shade it in. Okay, I'm not very good at shading in with the mouse, but you get the picture. Okay. Here is our formula. Now, you guys, when you do your got it problem, you're actually going to start with V equals capital B times H. Okay, and then you're going to start, this is your second step. We're going to change that capital B, which is area of the base, to length times width, because that's the base right here. Then all we have to do is plug in. Our length is 5, our width is 4, our height is 3. Multiply it all together and we get 60, so our volume is 60 cubic centimeters. Okay, why don't you try this got it problem right here? So go ahead and pause the video. Alright, let's see how you did. First, I want you starting off with this formula right here. If you don't have this written, write it in, because every single time you do volume, no matter what shape, you're writing this formula. So V equals base times height. Your second step, I want you to change this capital B to the area formula for the base. If you take a look, your base is a rectangle. So what's the area formula for a rectangle? Length times width. So we replaced capital B with length times width. And then we left our height in there. Okay. The next step, let's plug in what we know. Your length is 9.5, your width is 5. Now if you have those two switched around, it's okay. That doesn't matter. Okay. Then the height of the object is 3. That means that there are 3 layers of this base right here. Okay. Multiply it all together, and you should end up with 142.5 meters cubed. Now make sure you put your units in here. It's cubed because now we're talking 3-dimensional. Okay, that's the difference between volume and area. We're in 3 dimensionals now because we're dealing with geometric solids. Alright, let's look at another figure. Let's look at our second figure, the triangular prism. Okay, it is the same concept. Okay, you can see right here that we're still using this generic formula. Okay, then what we'll do is we'll take this base and we're going to make it more specific to the base of our triangular prism, which happens to be a triangle. Okay, so it's the same. You've got one layer, which is the area of your base, which is your capital B. Okay, I could write a capital B in here. That's the area of your base. Your height tells us how many layers of this base there is. Okay, let's look at an example. Okay, here they started with capital B times H. Well, your base now is a triangle. Ooh. And the triangular formula is, they should have another step in here. You will have another step in here. 1/2 times base times height times the height of the volume. Okay, so you can see that your 1/2 times the base of the triangle, and then you can have those reversed too. 6 times 8, 1/2 times 6 times 8, that gives you the triangle, times the height of the figure, which is 9, meaning there are 9 layers. Okay, so 1/2 times 6 times 8 times 9 is 216 feet cubed. Now I don't want you to get confused because there are 2 H's in here. This formula right here is specific to the triangle only. The last height right here is the height of the solid. Okay, how many layers there are. Why don't you guys pause the video and try the got it problem for triangular prism. Okay, so hopefully you started with your generic formula. V equals capital B times H. The second step, you should have changed this B to 1/2 base times height. If you use base times height divided by 2, it's okay, it's the same thing. Okay, now again, don't get confused with the 2 H's here. This is specific to the triangle. This is specific to the height of the figure. Okay, so let's plug in what you know. 1/2, the base is 4, the height is 5 of our triangle right here. The height of the solid is 7, meaning there are 7 layers of our base. Multiply that all out and you should get 70 inches cubed. Okay. They have one last example in here. Okay, it says which lunchbox holds more food? Well, when dealing with volume, you're talking about how much something holds. okay, how much space it takes up. So all you have to do is find the volume of each box and compare it. Lunchbox A, you take 7.5 times 3.5 times 10, and you get 281.25 inches cubed. Lunchbox B, 8 times 3.75 times 9.5, 285 inches cubed. So lunchbox B actually holds more food. Okay. So what you guys need to do right now is go ahead and try your guided practice problems, okay? And we'll check them in class.